so now we're going to look at areas above and below the x-axis. So I've said here, the graph shows the function y equals 2x. Evaluate the integral between -2 and 0 and 3 separately. Okay, so what does this look like? Well, put yellow here. So I want to integrate between -2 and 0. Okay, so this yellow triangle here, basically we want the area of that triangle. And then between 0 and 3, we want the area of this triangle here. Okay, so I'm going to work them out separately. This is fairly straightforward. So let's stick to the colors. So the integral between -2 to 0 of 2x dx is equal, well, it's quite straightforward, increase the power by 1, divide by that power, 2x squared over 2 between 0 and -2, which is equal to, well, substitute 0 in for the first one, that's just going to be 0. Then it could be -2 squared, okay? So this is equal to -4, right? Just bear with. Negative area seems pretty weird, but we'll come back to it. Okay, so the second one, the integral between 0 and 3 of, well, it's just going to be the same, isn't it? 2x dx, so x squared between 3 and 0 becomes 3 squared minus 0, which is equal to 9. Okay, so you're left with these two values, -4 and -9. Right, so knowing that, next part of the question is saying, what if we just integrated it, instead of doing it in 2 steps, what if we just integrated it as 1 step between -2 to 3? Then that would save us doing it twice, wouldn't it? So let's do that. So I'm just gonna, because it's just the same as before, I'm just gonna go straight to here. So it's x squared between -2 and 3, which is equal to 3 squared minus 2 squared, which is equal to 9 minus 4, which equals 5. Okay. So what happens now, right, if we just calculate the sum of the 2 areas of the pink and the yellow triangle? And what I'm talking about is just in the traditional sense of just length times breadth times height. What would we get? And then we add them together. Because what you can maybe think, well, it's just the area between the area created in these limits, so it should just add up to be the same, because that's basically what you're doing. Integration is the sum of the area under the graph, right? That's what we have believed up till this point. So if we take the first one and we just call it triangle pink is equal to 1/2 times the length, which will be 3 times the height, which is 6. So that's equal to 9. And then T yellow is equal to 1/2 times 2 times 4. And you see, it's just 4 because we're just measuring this as just an absolute length. We're not worried about it being negative. This is still 4 units long objectively, if that makes sense. Rather, it doesn't matter whether it's what directions it's pointing in. So this equals 4. Okay, so what is the total going to be? Okay, get the right pen. So T is going to be Ty plus Tp, which is equal to 13. Okay, Right, so that seems a bit weird because um, because when we worked out the area here, we only got 5, but here we're getting 13. So how does this work, right? Well, basically, the way that the formula works is it really basically calculates between the line and the x-axis, right? So in this way, it says everything above the x-axis is positive and everything below the x-axis is a negative area. Now, it's weird to think of areas as being negative just because of the way we measure stuff. In the real world, obviously areas can't be negative. But area is more of a word we use to describe this kind of shape underneath the graph. Because sometimes you won't always be measuring something like area. There's sometimes things will be able to be negative. But in this scenario, I think it's easiest to think about it like this. So like, as I've seen here, I've color-coded it. Areas above the x-axis are going to be positive, and areas below the x-axis are going to be negative. So the best thing you can do is sketch the problem. Often there's a sketch provided, but if not, you might have to sketch the problem. And then what you want to do is work out the area above and below the x-axis separately, then add the areas together as if they were all positive, okay? So that plus that, would give you the total area. But if you calculated from 0 to 4, it wouldn't. It would be taking these two away from each other, which is not what we want to do. Okay, I'll do an example to explain this. But yeah, it can seem a bit counterintuitive first time you see it.